Hey, hello guys, welcome back to my channel. You're watching Farm Betty, where learning is made simple and easy and fun. So today you're going to learn. So volumetric analysis is the adding of both known concentration and unknown concentration together. So the reagent or the substance we used here are termed as titrant, titrate. This titrant is present in the burette and titrate is present in the conical flask. So burette has the known concentration, whereas the conical flask has unknown concentration. So while you are doing experiment, we usually take the conical flask into the titration burette and we usually do some reaction, right? This is known as titration. So the solution which is present in the burette is called standard solution, and we actually add a substance to find out the end point, right? That is known as indicator. And then at a point where there is the reaction completed, just completed between the titrant and titrate is called as equivalent point, and the point at where they show the visual change is called as end point. Okay, so the classification of volumetric analysis four types: chemical method, physiochemical method, microbiological method, and biological method. So chemical method is further divided into volumetric method, gravimetric method, and gasothermic method. So chemical method we all usually do in the laboratory. Volumetric method, we add the known concentration of substance to unknown concentration and determine its strength. So this is what the volumetric analysis. The volumetric analysis further divided into acid-base titration, oxidation reduction, non-aqueous titration, precipitation titration, complex somatic titration. So these all has been given in a separate chapter. We will learn in the separate videos. So first one is the acid-base titration. So titrating the acid with alkaline and alkaline with acid is known as acid-base titration. For example, assay of sodium hydroxide, assay of boric acid, ferrous sulfate. These are all the example of acid-base sulfate. Next one is the oxidation reduction titration. So here the both oxidation and reductions takes place in the standard solution so that we can get an end point. So it is further divided into permanganometry, iodometry, chromatometry, bromatometry, serimetry, and titanometry. There are 6 types totally. This permanganometry is based on the titration with the potassium permanganate, and iodometry is based on the titration between the iodide. Next one is the chromatometry, which is depend on the titration with the potassium dichromate. Next is bromatometry, which is depend on the potassium bromate. Next, serimetry, which involves the seric ions. Then titanometry involves the titanous chloride. So these are the titration involves the standard solution as the what I told now. Next one is the non-aqueous titration. So non-aqueous titration is the titration does not involve water, because while adding the water the solution does not get the satisfactory endpoint. So the reagent which are used here in the non-aqueous titration is weak acid or weak bases. So next one is the precipitation titration. So this is the titration which involves the precipitation. For example, sodium chloride with the silver nitrate. Next one is the complexometric titration. This involves the complex formation in the solution. That is known as complexometric titration. It involves the example of magnesium sulfate. Next, gravimetry. Actually, gravimetry take or consume more amount of time, so it cannot be done in the laboratories. So it mostly done in the large industries or any time consuming areas. So this is analyzed by weighting the substance and isolating the substance in the purest form and doing the experiment. Next, gasometry. So it involves the amount of gas which is evolved in the particular reaction. The gas evolved in the reaction is absorbed and then done the experiment to know how much gas is evolved and how much gas is absorbed in the reaction. Next one is the physiochemical method or instrumental method. This method consists of more instruments which are used in the experiments like electric potential absorption spectrometry, atomic emission and chromatometry are present here. Next one is the microbiology method. In this method, the growing of bacteria is involved. Next one is biological method. It involves some biological assays and some precipitation in the biological methods. So this was the basic explanations of the volumetric analysis and their classification. So in the later things we will learn the complexometry precipitation separately. Before that we should know what is the difference between the primary and the secondary standard. So the primary standard is a compound of sufficient purity from which a standard solution can be prepared. A primary standard solution can be prepared by direct weighting methods. So what are the things should be required for a primary standard substance should be undergone? It must be easy to obtain and it should be 100% purity. And 0.01 to 0.02 percentage of impurity is tolerable, but it should not absorb any atmospheric air or any gas from the atmosphere, and it should not be hygroscopic, and it should be show high equivalent weight, and also it should not be used in the any of the small titration error should not be obtained here. It should be readily soluble in the any condition of the solution. The examples are acid base titration, alkalimetry, acidimetry. We usually use the potassium hydrogen pentylate, right? That is what the example of primary standard. Then using of sodium chloride, that is an example of primary standard. The some of the things we use in the experiments are the best example of the primary standard, which used in the burette, right? That is what the example of primary standard. Next is the secondary standard. So secondary standard is a substance which may be used for standardization and whose content of the active substance has been found by comparison against the primary standard. So secondary standard which may be having more amount of impurity or less amount of impurities, which has been compared with the primary standard and calculated the known amount of impurities or known amount of quantities, concentration, and with the molarity or normality, and the impurities found out. The best example of secondary standard is sodium hydroxide. But sodium hydroxide cannot be used as primary standard for some reason, because it absorbs water and oxygen from the atmosphere. As we know, primary standard should not be used as should not absorb the atmospheric pressure or atmospheric water or anything else. So it cannot be used as primary standard. Some of the secondary standard can also be in as primary standard too. So this is what about the volumetric analysis chapter. I think you have clearly understand this. We can see in next video. Tata, bye bye. See you later, and don't forget to subscribe my channel and click the bell icon and comment if you need comments, compounds chapter detailing or any notes of compounds. Comment me. I will send you that.